Good evening, everyone. Don't have many audience, so we're good to start, right? Yeah. Okay. Hello, everyone. Good evening. This is Navnit. I'm a senior solution architect specialized in data and AI. Along with me, my friend Gagan.
Good evening, everyone. My name is Gagan Brahmi, and I am the senior solutions architect for analytics at Amazon Web Services.
Okay, today we are looking to present how you can build the AI-ready data foundations. And again, this AI-ready data foundation is kind of a conceptual topic, more of like it's varied between organization to organizations. Everyone has its own definition for the AI-ready data foundation look like, but we'll try to see how we can able to go and define what all key characteristics offered by the OpenSearch in order for you to go and use it for your AI application. So this is me. Feel free to connect. This is me and Gagan. Feel free to connect us over LinkedIn. I'm an author of a book called AI-ready data blueprints. This is an early preview, and we'd love to have your feedback. If you get an opportunity to read and provide some feedback there. Also, a couple of years back, I wrote a book on the data wrangling on AWS. If you know, there was a product called data wrangling, open source product. So I've wrote about it as well. Okay.
I've done multiple hats over the years. I've been a consultant. I've been a DevOps engineer. I've also been a system engineer. And lately, right now, I'm a solutions architect. I've been working with distributed computing and distributed streaming frameworks for the past 16 plus years.
Cool. So this is how the agenda look like. We will be starting is what is AI-ready data foundation. We set the stage. Thereafter, we will be talk about why you need AI-ready data foundations, challenges of building the AI-ready data foundations, and then why choose OpenSearch for an AI-ready data foundations. Feel free to ask any question in between, but we kept some time aside for us to have the Q&A, okay? So when we talk about AI-ready data foundations, we are looking to keep 3 goals in mind. So our traditional system, which was built around the traditional AI, was meant to serve the analytics use cases, meant to serve the BI use cases, and search was a part of it, but was not a center of many organizations. They were using search just in a case, serve their applications if they have any e-commerce application or any in-house application where search is being needed. But with the Gen AI or evolution within the Gen AI, now search has become the core component of the data foundations. Other is we need data. So earlier when we talked about in the traditional systems, we had the data. If you will be running the data in data warehouses, you will be using for the BI, you will be have data sitting into the data lake, you will be using for querying your analytics engines. Whereas when we talk about Gen AI, it just do not need the data from very specific system. It just needs the data from all across the system. Also, the data are very unstructured in a manner like not very clean. It's coming from PDFs. It's coming from the emails. It's coming from all over the places. And you're looking to see when you have this data being ingested, you will be have this data being ingested in a very clean manner. The quality should be high, as saying goes, right, garbage in, garbage out. So when we talk about the key characteristics of the AI-ready data foundations, we will be primarily focused around the data quality. How good your data is and how easily you're able to go and retrieve those data. Of course, the diversity is like bringing the data from different data sources, have those data being stored within your data platform. Other is timelessness, like you will be able to go and retrieve those data in a near real time, as well as you should have governance in place where you're able to have a role-level access control, you can have a tag-based access control, you're able to track who's accessing what kind of a data, etc. And then, of course, you're able to go and discover those data. So your platform have a metadata being stored, whether it's technical metadata or business metadata. And more importantly, observability, like you can be able to go and see how the data is being consumed, what all API call has been made, etc., etc. So OpenSearch do not fit all the characteristics around the AI ready data foundations, but it has a component around it has a component around to satisfy the various characteristics which has described. So why we even need a AI-ready data foundation in very first place itself? So AI is, especially the Gen AI, is the biggest challenge with the Gen AI is that hallucinations. Even though people are adopting it, still they do not believe the outcome or the outcome which we are getting from those models are accurate, or they are hallucinating a lot. So the idea is, like, when you will be going and using a platform, the AI-ready, the data should be clean enough, or the data should be tracked. You're able to track the data, so you can able to go and confidently say the output which you are getting is inaccurate in very first place itself. And also you will be having the governance in place around the responsible AI, where you can able to ensure whosoever is having an access to the data, they will be using responsibly, and you can only able to do that when you're able to track the data. Other one is the scalability, because you're looking to start small, but you're looking to grow fast. So you will be deploying your chatbot, where a few people will be using in a dev and test. However, you're looking to see when you put into the production, that consumption will go really, really high. So it also able to go and handle those large amount data, and more importantly, when you will be retrieving the data, this data retrieval should be fast enough, so your user or end user should not need not to wait for a longer period of time. There is definitely around the trust and ethics. This is more goes into the of the people, like when we talk about any application, it has a people, process, and technology part. So this part primarily go around the people and process, how you've been defining and processes and people around your organizations to ensure data is being used or ethically, data are being trusted, etc. So the governance should be very critical pillar around it. And of course, the efficiency, right? You can able to it's not rely on the traditional ETL pipeline which we used to have. You wanted to have the data being consumed or being ingested automatically, have been ready for your application to use those data right away. What it will helpful is that will help you in the speed up your go-to market. Like you can have your applications going into market in a very fast manner. Okay. So as we have learned, what is the AI-ready data foundation and why you need an AI-ready data foundations, let's talk about the challenges which we are having currently and how the modern AI or data AI is solving this problem. So if we talk about the traditional system, it was built around 2-3 years back, where we had primarily around the structured data. So it's coming from the data like databases, etc. And we were looking to have much more deterministic output. Even if we are referring to the AI ML, we were knowing how the prediction, how the output is going to be. It primarily built around the batch processing, though it's near real time, but still it was a batch. It was meant for a very static query because we know what kind of a dashboard we are building. Those are the pre-canned or predefined dashboards which was built around. Other one, it was if we talk about very specific to search, it was very catered towards the keyword search, where you will be your end user will be searching based on the keyword. Whereas when we talk about now the traditional or modern AI ML system, it was primarily built around the semantics. So you do not know how the customer is looking to use your application, what all query they're going to ask, if that query even makes sense in very first place itself, right? So it should be flexible enough to handle those user requirements. And at the same time, user also can go and ask that very specific keyword search. So there is an example when you will be going, and I will be showcasing as a demo as well. So if you go and look for a shoes, hey, can you give me a tracking shoes? You're opening, you're just asking in a very semantic manner where you are having some intent. But when you go down, okay, I really like the shoes. Can you show me a specific Nike shoes or Adidas or any other brand? Then your system should not be doing the semantic search, then your system should be doing the keyword search, because then your search retrieval will be faster. In addition, right, you will be looking to go and bring those structures, semi-structured data, where structure, what's the pricing look like, etc. Whereas in unstructured data, you're looking to go and write those descriptions. If user is providing comments, those comments get aggregated. You must have seen in our Amazon.com. What we did is now the AI will be aggregating all the comments which is being provided by the end user, and those aggregated comment will be showing on the product page. So the question is why we need, when we talk about AI-ready data foundations, why OpenSearch will help you to go get started. As I mentioned earlier, when we talk about AI-ready data foundations, everyone has its own interpretations, everyone has its own need, but the key characteristics remain same in all those use cases. So why OpenSearch will be a good place to get started? Because again, it will be providing a lot of plugins for you to go and get started, starting from the ingestions. So we will be providing KNN plugins for you to go and get ingest your data. Not only through our Bedrock, but it's also integrate with an open third-party embedding models where you're able to go and embed the data when you will be ingesting. I will be going and giving much more details later. Also, it has a hybrid search capability. As I told you, it should not be around the semantic always, though we are talking a lot about the semantic search, but it will be combining with a keyword search as well. And based on the user intent, what it's trying to do, you should be able to route from the semantic search from the semantic search to the keyword search. Also, re-ranking is very critical when we're talking about this search. So we have the inbuilt re-rank functionality. So this way, your user not only getting that good result, but also they are getting those results which they are getting should be re-ranked properly. You can able to go the relevance tuning. So more importantly, where they are, what kind of if they're they are multilingual. If they are asking those questions in English, and later they will be switching into some different context. And also you can able to set based on the age, criteria, geographical locations, etc. So those relevances tuning, you can able to go and perform it. Other is having, if you're building the GenAI application or AI application on top of it, the most important and critical part is extracting those data in a real time. So with an OpenSearch, we offer the millisecond latency with you can have your vector being stored, and then you will able to query on those vector within sub-second latency. So that is important. Other thing is very critical is around the ecosystem. As I said earlier, right, all the characteristics being offered by all the characteristics which we have around the AI-ready data foundations, OpenSearch do not have all of them in place. But with the tight integration within our AWS ecosystem, such as we do not have an integration, OpenSearch do not offer the knowledge graph, but with the integration with the Neptune DB within the OpenSearch within AWS, it allow you to go and bring the data and have the relation being built there as well. It is also directly integrated with the SageMaker AI, so you can have any open source model being hosted there, in which you can able to go and use within the SageMaker. It integrates with the Lambda, so it will be help you to do the event-based triggering or event-based processing as well. So when we talk about OpenSearch, or when we talk about the building the AI-ready data foundations, it goes through the multiple stages, like how traditional pipeline goes through from the ingestions, enrichment, vectorizations, indexing, search, and generation, for sure. When we talk about the index, like when we talk about the ingesting, so we will be bringing the data, and when we are bringing the data, we are bringing the data from the diverse data sources, not only from such as PDF file, databases, NoSQL databases, logs, etc. And it's a multi-model data, right? When we will be ingesting the PDF, it's not only contain the text, it also contain those images as well. So how you can able to go and bring those data in a real time, able to chunk it and have those data being stored into your vector DB, and later you can able to use and perform search on top of it. That's what we're going to cover in the later part of this presentation. So let's talk about the search, right? So when we talk about the search, it has three broader component. One is around the ingestion. You'll be looking to ingest some data. So in order for you to perform the ingestions, we will be providing multiple options. For instance, you must have seen our partner booth, RN, they provide the multi-model data processing, as well as you can able to use open source Llama parser. You can able to use our Amazon Bedrock data automation that allow you to do the multi-model data processing. Along with it, you can also able to use purpose-built services like TextRec, Comprehend, Recognitions, and of course all the model which is being stored in our Bedrock, or as well as in SageMaker AI. Once the data is being stored, Gagan gonna go give much more information on how the processing part or how the data is being get stored and how you can able to retrieve it. But the other part is like, when you will be talking about retrieving those data, one part is you looking to go and put a filter on the data itself. Why it is important, or especially when you will be doing the keyword search. So this will be you not going and accessing the entire data set altogether. So this is very, very critical for you to ensuring when you will be building those semantic search or search application for your Gen AI. With that, I will hand over to Gagan.
Thank you, Navnit. So in the next few slides, I'm going to talk about how Amazon OpenSearch service can really become the centerpiece of your overall AI applications and the overall AI data foundation strategy. I want to start off with an analogy. So remember how your food ordering experiences have changed over the years. Previously, you used to go around and say, you need to remember the exact menu item in order to place an order at a restaurant. Then things evolved, and restaurants started to understand concepts like, give me something spicy, or give me some vegetarian options. Now today, the modern applications or the modern experience is such that you can actually show a photo of a food item that you liked elsewhere, and the restaurants would recommend you similar items that you would probably like as your dietary preferences. Even the modern applications, the food ordering applications has evolved where it has reviews, it has dietary preferences, and they even have chatbots to provide you or help you order the right food. OpenSearch's machine learning search has evolved similarly from the actual menu item name to understanding and identifying or image recognition. It has evolved into a modern search application. I'm going to start with sparse retrieval and the different kinds of searches that is available today, starting with sparse and move on to the dense. In sparse, you have the good old lexical search. Now, lexical search is, again, it's the foundation of OpenSearch. That is where OpenSearch really excels. It is a BM25-based keyword search. That is where you have things like term matches. If you want to search things like OpenSearch tutorial 2025, it will return the results with exact documentation or pointing to the exact documents. It is fast, it is interpretable, and it works out of the box. You don't have to do any sort of training. Within sparse retrieval, you have neural sparse search, and that takes it to the next level where it uses transformer models to understand the semantic meaning of the queries being asked. It is still interpretable, unlike the dense models. Next, we have the dense retrieval mechanisms. Now, this is where the overall OpenSearch really shines for AI applications. You can use vector embeddings, store them in OpenSearch, which can be used to unlock certain, to unlock some of the use cases where you can provide contextual responses. Now, it's not just about text anymore. Within dense retrieval, you can also use things like multimodal. So why you only want to search text? You can also now store these vector embeddings or vector embeddings for images, audio files, video files in the same vector space and search across modalities. Now, we talked about sparse and dense, but why do you have to choose one or the other? Why can't you have both? And that is where hybrid provides you that flexibility, where you can choose the go-to lexical search and combine it with vector search and provide more accurate responses. The last thing I want to talk about in terms of search is the conversational search. The only thing that we are really utilizing in conversational search is the storage of the context by using the memory or using the storage functionality within OpenSearch. So this really unlocks a lot of modern applications, things like chatbot, which is a very, very common use cases that we are seeing. Since we are talking about AI applications, one very important thing that I want to discuss and talk about a high-level architecture is the retrieval augmented generation, or RAG. Now, I believe everyone in this room understands what RAG is. I don't really have to explain this. Yes? I'll take a yes. Okay. So what RAG really does is solves two critical challenges. The one that Navnit mentioned is hallucination. The large language models out of the box may not find the accurate information. And the second thing that it also addresses is your stale knowledge. Since these large language models are trained on a data which is a point in time, it does not have the latest information. Additionally, RAG will also address certain important use cases like providing domain or industry-specific knowledge. Now, in this architecture, for example, if you see at the bottom right-hand side, we are ingesting source documents which actually become your knowledge, and this can be your industry knowledge, your organization knowledge, or your domain knowledge. These are stored inside OpenSearch. OpenSearch's ML Commons framework allows you to embed, to communicate with a model hosting provider, something like Amazon Bedrock in this case, to embed these source documents and store them as vectors. Now, once you have these available inside your vectors, a user query can now be converted into vector embeddings, try to match all the relevant documents using the source documentation, combine the user query and the source documentation vectors to build a contextual prompt and augment it into a prompt and send it to large language models to respond. The next thing I really want to talk about is the agents. Now, what we are looking at agents is an evolution from a simple Q&A solution into more of a problem solvers. Think of them as a large language model with a purpose, and they just don't respond, they actually solve problem or accomplish tasks. Now, if you give a task to an agent, it will use the best path and use the reasonings with all the available resources to accomplish a task. Every effective AI agent has three main components. First one is the tools. The tool is something like, or is the available resources besides the language that a large language model or large language model has. So, for example, if you're doing a research, you may be using online search engines for some research, or you may be using a calculator to perform certain calculations. It's similar to what tools available for an AI agent is. Now, if I want to put it in context with OpenSearch, these will be things like your search APIs or aggregation queries or index lifecycle management, or even talking to external data sources. The next important component of an AI agent is the memory. Now, this is both the short-term memory for keeping a conversational history, as well as long-term memory, where you can persist the long-term conversational history to identify patterns and perform historical analysis. And the third important concept is the planning or the reasoning, where LLM really shines. It uses techniques like self-reflection or chain of thoughts to determine and check their works using self-reflection, for example. And it can also determine if I need to use different routing mechanisms to accomplish a given task. Now, how does an agent actually works? It's called thought action observation loop or react patterns. And what it really does, I will in this example is I will explain you in an example where, say for example, you want to try to find out the sales information for last month. So the query would be find out all the sales data for past month and compare it against the same month previous year. Now, what AI agent will do, it'll think and try to reason, okay, so I need to query two different data sets for two different time frames. Now, based on the thought process, it will actually act and execute search queries across two different time series, and the next step is going to be observe. It will observe the results. Now, once it's observed the results, it will then go into another loop of thought, where it'll think, okay, now I have the data, I need to return the results, but should I calculate the percentage, and should I also return the factors which impacted the difference? So say for example, the return result is for September 2025, the revenue is 1.5 million versus September 2024, the revenue is 1.1 million. That is where it will take that next thought process. Now, with this thought, it will take another action. And with an action, there will be another observation. So the loop will continue until it retrieves all the information and returns response. An agent knows when to dig deeper, when to ask questions, when to stop, when to dig deeper, or even when to ask for clarifications. So the important question is that, okay, we already have RAG. Why do we need agents? So, well, the problem with traditional RAG is that it is powerful, but it is passive. You ask a question, it responds. So it essentially is a one-shot operation. Now, for example, consider this query that tell me all about shipping complaints and what are the different product categories that has been impacted with this. A traditional RAG will go out and identify and look for shipment complaints data and summarize it and return the results. Versus an agent-backed RAG will understand that this query needs to be queried across two different data sets in two different time frames, and then there has to be a correlation between the complaints and the product categories. So what is essentially what an agent RAG or agent-backed RAG will bring is a dynamic query refinement, where it will, if the initial query results were poor, it will determine that it will go ahead and move to another query. So it will try to go from, say, lexical search to semantic search. Or if the relevance score is low, then it will try to go to fuzzy matching. It will take those autonomous decisions to determine if the return of the results needs more refinement. The next important thing it brings is multi-hop processing. In this case, an agent, we are still using RAG under the hood, by the way, but the agent will chain together multiple RAGs and execute them. So for example, if the question is, what is your best-selling product? Now that will lead to another question is, what are the reviews about that product? And that will then lead to another question maybe, what are the recommendations by the customers to improve this product? So these multi-hop thoughts and decisions is taken by an AI agent and executes those query based on the reasoning. Source validation is another important aspect that a RAG-based, agent-based RAG really brings on table. So say for example, if there's a conflict, a product says the return window is 30 days, another document says it's 60 days. Agent will automatically, will go ahead and proactively identify the timestamp of different documents and determine which should be the authoritative document and resolve the conflict. Lastly, adaptive context window. Agents can intelligently manage the context size. So if, for example, you have a very large query, it will know that this query is important and needs to access multiple documents. It will increase the context size and retrieve more documents from your RAG. Versus if it's a simple fact check query, it is going to be just shortening the context size. What this really improves is your cost and also improves the latency. So if I want to simply put, RAG makes your responses accurate, but an agent makes them intelligent. And if you combine together a RAG, agent-based RAG in OpenSearch, they will transform your infrastructure into an autonomous knowledge system and not just answer questions. It will actually solve the problems for you. Now that we understand the RAG architecture and all the different components that we bring along with agent RAG, let me showcase how OpenSearch makes the pattern a production ready for things like built-in conversational search, which unlocks use cases like chatbot. Now, this is not just an LLM search anymore. It's more about creating intelligence, context-aware conversations, and interacting with your data. We are not doing anything, so keep in mind, we are not really building something new. Your existing searches can continue to remain the same. Your model flexibility remains the same. What we are building with conversational search is we are just adding an ability, and that ability is to remember things. What the conversational search provides is it maintains the history so that you can keep a conversational context across multiple queries within OpenSearch. And all of this can be hosted inside Amazon OpenSearch service. Now, I want to end off in the bigger picture, right? Now, we have built this functional conversation application like chatbot, for example. Now, OpenSearch delivers some of these key capabilities, like RAG pipelines and conversational memory and flexible model ingestions and intelligent searches. Users can use LLM model hosting provider like Bedrock and use models like Nova or Claude, or even custom models hosted in Amazon SageMaker AI, for example. But everything can be seamless. You don't need an application change. Users can switch between different models without really making any code changes. And everything is handled by OpenSearch's ML Commons framework. Now, when I say intelligent search, the searches can evolve in a similar way. You can always start with lexical search, try to add intelligence with semantic search, move on to dense search, or even have the best of the both worlds by having a hybrid search and conversational search. Next, I will have Navnit talk about a quick demo and show all the capabilities that we really described here.
Fair enough, thank you, Gagan. So, again, where is demo? Yes. So this demo is hosted on the Hugging Face as well. You always can able to go and I will put the slide here for a few seconds so you can take a screenshot, or if you want to go into and bookmark that link as well. This will show you the capabilities which we just talked earlier when Gagan was showcasing this slide. Okay, how, and when we say like, okay, why your OpenSearch can be a good platform to you get started and build your AI-ready data platform, because it offers all the capabilities around the embedding. It's able to offer the capabilities around the, if I go, yeah, it offers the capabilities around the indexing. It has the capabilities around the managing the doc. It has a memory indexing, everything as such. So not only it will be supporting your RAG workload, as well as it will be supporting those agentic workload along with supporting this hybrid work as well. So let me show you. I may need to go and mirror. Okay, so this is, again, as I said, like this is being hosted on the Hugging Face. You can able to go and use it. I will show that later because it took some time. Is when you first fire the query, it takes some time to spin up. So that's the reason I kept it ready, just to kind of show you. So in this one, we are looking to showcase that hybrid search capabilities within that agent, right? Where when you will be going and asking questions in this one, first one, give me the shoes suitable for the tracking, right? It's where the user being asking a question where it has an intent where they wanted to know if there are shoes available or the shoes which will be helpful for them or suitable for the tracking, and it went ahead and extracted those information for you. Thereafter, once done, then user will be going and asking the questions, do you have a similar shoes in a white color, right? So this way, the user, this is when it went ahead and said like, okay, we do not able to go and find the catalog. We're not able to find in a catalog where you're talking very specific, talking about the tracking shoes within the catalog. Do you want me to go and extract those shoes? They are not very specifically for the tracking, but they can be used when you will be going and performing, running, and etc. So I said like, yes, can you help me with finding those information? So what is happening right now is the user will be interacting with an agent, and based on the agent, as Gagan has mentioned, it's making not only bringing the accurate data, as well as this search is becoming the intelligent in terms of user. So user will be providing the intent, and it's extracting this an output. So it said like, okay, I do not have the very specific tracking shoes, but I have shoes which can be, you go for walking, running, etc. So I said like, okay, can I display those shoes? I said yes. So when I said like yes, the user this agent, our solution or agent able to go and extract those shoes from the Nike, and it provided me, these are the 2 shoes will be available. I said like, okay, this is nice, but I wanted to have these shoes in those for the Met. If you see here, in first one, I have provided yes, please. It went ahead and provided me the Nike woman shoes. When I said like, okay, can I get it this for the man? It has those context. I'm talking about Nike shoes. So what it will do is, now it do not went into perform the semantic search across the entire data set. What it will be doing, it will be the keyword search, right? Remember I talked to you about how you can able to do the filtering. So that is what it able to have that intent, it able to understand this person is looking to get the similar kind of shoes, but for the man. So it able to go and extracted those information for us and provided that. In this demo, this is one example where we have shown you that hybrid search, whereas we have also other search kind of available for you to, you can go and explore, where you're able to see how the AI search look like, how you can able to perform the multimodal search, and of course, agentic search, which I just showed it as a part of the demo. With that, I think we are open for any Q&A. Meanwhile, as I said earlier, please do provide any feedback if you have for our book. We love to get the feedback from you. Any questions? We still have a 2-minute 40 seconds. So maybe we can throw some questions. Are you guys working on, or have your data being using OpenSearch as a primary platform for you to go build your AI application? Anyone? Okay, fair enough. So with that, thank you very much.
Thank you so much.